Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 4. The lesson is called Relation between the two roots of the second degree equation and the coefficient of its terms. This lesson is very important to us because we are going to use this relation later to create the equation, the quadratic equation or the second degree equation. Let's start the lesson. First, if the two roots of the equation ax power of 2 plus bx plus c, this is the form of the equation. If we called this roots L and M, okay, then L equal negative b plus square root b power of 2 minus 4ac over 2a, for example, and M equal negative b negative square root b power of 2 minus 4ac over 2a. Okay, now we have to conclude the relation by the next proof, but the next proof is not required for you, but it's make you understand what's the relation between the two roots. Okay, first L plus M. I'm going to add the two roots together like this: negative b plus the root over 2a, negative b minus the root over 2a. When we add two fractions, if we have the same denominator, so we write down the denominator and add the numerator. For example, if we have a fraction like this, 3 over 7 plus 1 over 7, we do what? We write down 7 and 3 plus 1 equal 4. This is what I'm going to do in the next. Okay, I'm going to write down 2a down and the whole numerator. Okay, I'm going to write them in the fraction in the numerator. Okay, now by looking carefully, we have root and we have negative the same root, so I can cross the two roots together like this. Okay, and we have negative b and the negative b equal negative 2b, and down we have 2a. 2 over 2 cancelled together like this, so I will have negative b over a. This is the sum of the two roots. So the first rule with us, L plus M, or the sum of the two roots, equal negative b over a. What is b and a? B is the coefficient of x, a is the coefficient of x power of 2, and c is called the absolute term. Okay, now let's know the multiplication of the two roots L times M. If the two roots again ax power of 2 plus bx plus c are L and M, and the two roots as we said before, let's multiply them. Okay, I'm going to multiply this fraction times this fraction like this. When we multiply two fractions, we do what? If we have, for example, 3 over 4 times 1 over 5, we do what? 3 times 1 equals 3, 4 times 5 equal 20. This is what we do in the multiplication. So I will do this in this fraction. First, I will multiply 2a times 2a, which is 4a, and then I'm going to multiply this expression times this expression. Okay, what we do, by looking carefully to the numerator here and the numerator here, we find difference between two squares, negative b plus and the negative, or two conjugate numbers, negative b plus and the negative b minus. It will be first times first minus second times second, like this. Negative b times negative b equal b power of 2, and root times root equal what inside the root? Okay, like this. b power of 2 minus the numbers inside the root, because when we multiply root time root, the root will cancel. Okay, so I have only the numbers inside the root. Down we have 2a times 2a equal 4a power of 2. Now I'm going to expand this bracket. Okay, b power of 2 minus b power of 2, okay, equal 0. Here b power of 2 minus b power of 2 equals 0, and the negative 4 equal positive 4ac. Down we have 4ac. Okay, now I'm going to cross 4 with 4 like this, and it will be ac over a power of 2, and also I will cross a with one of the two root of the two a down. Okay, it will be c over a like this. So finally L times M equals C over A. So briefly we can say that L plus M equal negative B over A, and L times M equal C over A. This is the relation. The sum equal negative B over A, the product equal C over A, and this is the relation of this lesson. Let's start the questions. Without solving equation, find the sum and the product of the two roots of each of the following equation. Number 1, four x power of 2 plus 4x minus 35 equals 0. Here a equal 4, b equals 4, c equals negative 35. Okay, the sum equal negative b over a, which is negative 4 over 4, which is negative 1. The sum of the two roots equals negative 1. Okay, the product you can write here in place of sum L plus M and L times M. Okay, the product equal C over A, which is equal negative 35 over 4. Okay, now number 2, 3x power of 2. This equation is not in the simplest form. First, I'm going to write the equation in the simplest form. 3x power of 2 minus 23x plus 30. I did what? I send 23 and the negative 30 to the left side. It will be equal 0. Okay, a equal 3, b negative 23, c equal 30. So the sum will be L plus M, which is the sum, negative b over a equal negative 23 equal 23 over 3, and L times M, Lm equal c over a, which is 30 over 3. 30 over 3 equals 10. So the sum equal 23 over 3, the product equals 10. Number 3, here a equal 1, b equal negative 3, c equal 0. Okay, L plus M equals negative b over a equal negative 3 equals 3 over 1, which is 3. Lm equals c over a, which is c here is not included. C equals 0, so it will be 0 over 1 which is 0. The next one, 2x minus 3 and x plus 2. I can solve this one by two different ways. First, I'm going to multiply the two brackets, okay, and simplify the expression to find the sum and the difference. But I have another and more simpler method. How come? I can find the two roots by solving the two brackets. How come? The first bracket, x plus 2 equals 0, then x equal negative 2. The second bracket, 2x minus 3 equals 0, then 2x equals 3, then x equal 3 over 2. Now this is L and this is M. L equals 3 over 2, M equal negative 2. So L plus M, I'm going to add 3 over 2 plus negative 2 like this equals equal negative 0.5 or negative half, and LM equals 3 over 2 times negative 2, which is equal negative 3. The second example, if the product of the two equations of the equation is negative 8 over 3, find C, then solve the equation in the set of complex numbers. Okay, see here, okay, I can find C by using the product. The product equal L times M equal C over A. So it is equal, in place of C I will write negative C because this is the given, and A equal 3. This one equal negative 8 over 3 equals negative 8 over 3. Therefore C equals negative C over 3 equal negative 8 over 3. It's clear that C equals 8. Okay, then C here equals 8. So the equation equal 3x power of 2 plus 10x minus 8 equal 0. Now I'm going to solve the equation by using the formula. A equal 3, B equal 10, C equal negative 8. So x equals negative b, negative or positive, square root b power of 2 minus 4 times a times c, 3 times negative 8 over 2 times 3. So we have two solutions. X1 equals negative 5 over 2 and x2 equals 1. Or you can use the calculator like this. Remember with me, mod 5 3. Okay, and here we have the coefficients 3, 10 and the negative 8. 3 equal 10 equal negative 8 equal x1 equal 2 over 3 and x2 equals negative 4. Okay, so we have negative 4 and 2 over. So the solutions are negative 4 and 2 over 3. Finally, solution set equals negative 4 and 2 over 3. Example 3. If the sum of the two roots of the equation is negative 3 over 2, find B, then solve the equation in the set of complex numbers. Okay, now we have the sum, which is L plus M equal negative B over A, which is equal negative B over A. Okay, B equal to this one equal as a given negative 3 over 2. It's clear that negative B over 2 equal negative 3 over 2, then B equal 3. Okay, so the equation is 2x power of 2 plus 3x minus 5 equal 0. Now by using the formula, or by using the factorization, or by using the calculator, I'm going to find L equal, or x1 equals negative 5 over 2 and M equals 1. So the solution set equals negative 5 over 2 and 1. The next example. Find the two roots of the equation, then find the other root of the equation, then find the value of A in each of the following cases. Number 1, x equal negative 1. This is the first root. The required is find the other root. So then I will find the value of A. Okay, to find the other root, okay, I'm going to use the sum. Why I'm going to use the sum? The sum depend on B and A. B and A are included, exist. B equal negative 2 and A equal 1. So I will use the rule which included B and A, which is the sum. Okay, so L plus M equal negative B over A. Now let x1 equal L. L equal negative 1. So negative 1 plus M equal negative B, which is negative 2 equal 2 over 1. Okay, then negative 1 plus M equals 2. By sending negative 1 as a plus, then M equals 3. This is the first required. The first root equals 3. Okay, now the second required. Find A. A depend on the product, because here this is the absolute term, or C in the equation. Okay, L times M equals C over A. So negative 1 times 3 equals, in place of C I will write A, don't be confused, and in place of A I will write 1. So negative 3 equals A over 1 equals A. So A equals negative 3. Number 2. Okay, if 1 plus I is one of the two roots of the equation x power of 2 minus 2x plus A equals 0. We took before in the last lesson that if one of the two roots is complex, then the other root is its conjugate. So here L equal 1 plus I, therefore M equal 1 minus I. It's very easy. Okay, now we have L and M. To find A here is in possession of C, okay, C which is the absolute term, so I will use the product L M equals C over A. Okay, LM equal 1 plus I times 1 minus I equals C. In place of C I will write C, I write A, and in place of A I will write 1, don't forget. Okay, to multiply this one, first time first, second time second. 1 times 1 equal 1, positive times negative negative, I times I equal I power of 2, which is negative negative 1 equal positive 1, equals A over 1 equal A. 1 plus 1 equal 2, then A equals 2. Example 5. Find the value of A and B in each of the following if number 1, 2 and 5 are two roots of the equation x power of 2 plus ax plus b equal 0. Okay, 2 and 5, this is L and this is M, for example, are two roots of the equation. Okay, to find A, okay, here A equal 1, B is called A, C is called B. Okay. Okay, now L plus M equal negative B over A. So L plus M, 2 plus 5 equals 7, equals negative B, B here in place of A. So it will be negative A over, in place of A I will write 1. Negative A over 1 equal negative A, therefore negative A equal 7. So let here negative 1 times A equal 7, so A equal 7 divided negative 1, so A equal negative 7. This is the value of A. Now I need to find the value of B by using the product. LM equals C over A. LM 2 times 5 equals 10, equals C. In place of C we have B, I will write B. In place of A I will write 1. B over 1 equal B, so B equals 10. Okay, this is number 1 in question 5. Number 2. Negative 3 and 7 are two roots of the equation ax power of 2 minus bx minus 21. This is L and this is M. Okay, L plus M. First I will start with the product to find A, because if I started with the sum it will be B over A, and we have here two unknowns, so it's better to start with the product. Okay, so L M equals C over A. Here A is called A and B is called the negative B, and C equal negative 21. Again, A equal A, B equal negative B, C equal negative 21. This is a given, it's not from me, it's from the given. Okay, so L times M, negative 3 times 7 equal negative 21, equals C. In place of C I will write negative 21. In place of A I will write A. Okay, it's clear here, negative 21 equal negative 21 over A, here over 1, so it's clear that A equals 1. Okay, now to find b, I'm going to use the sum L plus M equal negative b over a. So the sum negative 3 plus 7 equal 4 equals the negative b, which is negative b or b over a, which is 1 from here. So b over 1 equal b, so b equals 4. Okay, now number 3. Root 3i minus root 3i are the two roots of the equation. Okay, here a equals 1, b equals a, c equals b, or called b. Okay, now first I will start with the sum L plus M. This is L and this is M. L plus M equals negative b over a. So root 3i plus negative root 3i equals 0 equals negative b, which is negative a over 1. Negative a over 1 equals 0, so a equals 0. Then this term is not exist because a equals 0. Okay, now I need to find b. Lm equals c over a. This is the rule. Lm root 3i times negative root 3i. Root 3 times root 3 equal negative root again. Root 3 times negative root 3 equal negative 3. I times I equal I to the power of 2. I power of 2 equal negative 1, and we said before I power of 2 change the sign, so it will be negative 3 times negative 1 equals 3. Equal c over a. Here in place of c I will write b, in place of a I will write 1. B over 1 equal b, so b equals 3. Now let's study two special cases, the additive inverse and the multiplicative inverse. Okay, now this is a special case, as I said. Ax power of 2 plus bx plus c are, if they are additive inverse to each other, so they were, for example, in place of L and M I will write L and negative L. L and negative L because L and negative L are two additive inverse to each other, because we remember that the additive inverse is the number that we change the sign of the number. Okay, so L, its additive inverse equal negative L. Okay, now if I need to find the sum of L and negative L, L plus negative L equal to 0. So in that case negative b over a equal 0, because negative b over a is the sum, so it will be equal 0. Okay, in that case negative b over a equal 0, so negative b equal to 0, because if the fraction equal 0 then the numerator is equal to 0. In that case this equation doesn't include bx or doesn't include the middle term. So if the two roots are additive inverse to each other, so b equals 0. This is a very important remark. Another one, if they are multiplicative inverse to each other. Remember with me the multiplicative inverse. If we have, for example, 5, its multiplicative is 1 over 5. The multiplicative inverse we make upside down for the number. Okay, if the first root called L, then its multiplicative inverse is 1 over L, like this. So, by looking to the product in this time, the product is L times 1 over L equal 1. L times 1 over L equal to 1. So, C over A equal 1. Okay? If C over A, if two numbers so equal 1 by sending A times 1 equal A, so in that case C equal to A. This is a special case. If they additive inverse, then B equal to 0. If they are multiplicative inverse, then C equal to A. Remember with me this remark. Let's start example 6. Find the value of k in each of the following, which make number 1. One of the two roots of the equation is multiplicative inverse of the other. Okay, the multiplicative inverse, that means A equal to C. Okay, this is a special case. This is A equal 4k, and this is C, k power of 2 plus 4. Therefore, 4k or k power of 2 plus 4 plus 4 equals 4k. This is a given. Okay, now I have trinomial, so I will send 4k in this place and arrange the expression. It will be k power of 2 minus 4k plus 4 equal to 0. Now this is a trinomial. I can solve this trinomial by using the calculator or the formula, but it's better to use the calculator. It's easier. Or I can factorize this one as a perfect square. Okay, now A, B, and C, here 1, negative 4, 4, so x equal 2, and so here this is a perfect square, so k equal 2. Number 2, one of the roots of the equation is additive inverse to the other. The additive inverse, that means b equal to 0. Here b is k minus 1. Therefore, k minus 1 equal to 0. Send 1 there, then k equal to 1. Let's solve example 7. Find the value of c in one of the two roots if one of the two roots of the equation is double the other root. Okay, now let's let the two roots be. One of them is double the other. If the first is L, then the other is 2L. L and 2L. Therefore, the sum L plus 2L equals negative B over A. Negative B over A. Now I start with the sum because A and B are exist. It's better to start with the sum. Okay, so L plus 2L equals 3L. In the right side, negative B, which is negative 3 or 3, will be 3, A equals 1. So 3L equal 3. So L equal 3 divided by 3 equals 1. This is the value of L, or the first root. Okay, now I need to find C. L times 2L equals C over A, the product. L here equal 1, then 1 times 2 equals 2, equals C over A equals 1. C over 1 equals C, then C equals 2. Okay, now example 8. In this example, if the product of the two roots of the equation 2x power of 2 plus 7x plus 3k equals 0 equal the sum of the two roots of the equation x power of 2 minus k plus 4x equals 0, find k. Okay, here the product of the first equation equals the sum of the second equation. Okay, the product of the first equation here A, B, C. And here A, B, and C is not, C here equals 0 in the second equation. Okay, L times M Lm in the first equation equal C over A equal 3k over 2. This is the first equation. In the second equation, the sum L plus M equals negative B over A, which is negative K plus 4 equal K plus 4 over A, which is 1. Okay, therefore 3k over 2 equal K plus 4 K plus 4 over 1. I will make cross multiplication, 3k times 1 and k plus 4 times 2. Okay, 2 times k plus 4 equal 2k plus 8 equals 1 times 3k equals 3k. Okay, now I'm going to send 2k here with negative, therefore 3k minus 2k equals 8, so k equal to 8. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was